Hello everyone, welcome back to my channel. Let's solve the day 5 problem of April month. The problem statement says the XOR total of an array is defined as bitwise XOR of all its elements or 0 if an array is empty. Okay. Given an array nums, return the sum of all XOR totals of every subset of nums. Okay. So what they are trying to say is basically, if this is our input array, okay, the idea is to generate the subsets of this array. So what all possible subsets of this array? One would be the empty subset. In that case, if it is an empty array, as I mentioned, the XOR would be 0. The next thing is, the next possible subset is 5, and next is 1, next is 6, 5 1, 5 6, 5 1, 1 6, and 5 1 6. Okay, these are all possible subsets. Okay, so for each subset we have a XOR total. Okay, so this is the XOR total of this particular subarray. XOR total of 1 would be 1, and this is this, and so on and so forth. Okay, once we have XOR total of every possible subset, we have to do summation of all these subsets, XOR totals, and that would be our answer. Okay, so the brute force solution would be is to generate all subsets and identify the XOR total of each possible subset, and then do the summation of everything and then return it. Okay, so the time complexity in this case would be to generate all possible subsets. The time complexity would be 2 raised to the power n. The reason being, every element can be part of a subset or not part of a subset. So how many such choices I have? Okay, which I have 2 choices for the first element, 2 choices for the second element, so on up to 2 choices for the nth element. So the total number of choices would be 2 power n. So that would be the time complexity required, order of 2 power n time complexity to generate all possible subsets. Now that for each possible subset, what would be the time complexity to generate the XOR total? For a given subset, time complexity to generate the XOR total would be order of n. So the overall time complexity would be order of n times 2 power n, right? So let me just write it down here, so it would be a lot more clear for you. So for this element, I have 2 choices, 2 choices, 2 choices. So the total number of choices would be 2 cube. So it would be order of 2 power n. So okay. Now that to generate all possible subsets, this is the time complexity for each subset. Right. Now that let's say I have identified a subset of 5, 1. Now to identify the XOR total up to this particular subset, the time complexity would be order of n. So for each element, I have to compute the XOR total, right? So the overall time complexity will boil down to order of 2 power n times n. So this is when you try to solve it using brute force approach. Okay. So we can actually tweak the subset generation algorithm in such a way that we can actually reduce this time complexity to order of 2 power n. So how can we do this? Okay. So let me just draw down the how we will be generating a subsets for this particular problem. Let's say we have 5 1 6. Initially I will be choosing 5 in my subset. Okay, and I have to generate the subsets for this particular element. If I don't choose to have 5 in my subset, then what would be the subset which I will be generating for 5, 6? Okay, now that I have generated 5 in my subset, now I have to make a decision on one, whether I have to include or not. If I include 1 in my subset, then what would be the number of subsets I can generate with 6? If I don't include 1 in my subset, what would be the subsets generated with 6? Okay, the same if I have 5 1 6, there are no more elements to have, and if I don't choose to include 6, then this would be the thing. If I choose to include 6, if I not choose to include 6, if I choose to include 1, and if I not choose to include 1, so here I will be including 6, and I will not be including 6, here I will be including 6, and here I will not be including 6. So these are all possible subsets which I have generated, right? So we can actually tweak the algorithm little bit. Okay, so initially I have included 5 in my XOR. Okay, and then I have included 1 in my XOR. So current XOR, initially the current XOR would be 0. Okay, if there are no elements, let's say we have a variable called 0. So I will be first including 5 in my solution. Next I will be whatever the so far XOR I have, in that I will be including 1, right? Next whatever XOR I have, in that I will be including 6. Okay, so at any point of time I will be just updating my solution. Instead of generating subsets, I will be identifying what would be the current XOR, what would be the final XOR by including an element and not including an element, right? So this is the XOR by including 1 in the solution. This is the XOR which is including not including 1 in the solution. This is the final XOR, right? Including 6 in the solution, not including 6 in the solution. So let's have a utility function subset XOR sum, okay, which will basically takes 3 things. Okay, what is the XOR so far? Okay, and I have to make a decision whether I have to include the current element in the so far XOR or not, right? So if I choose to include, right, then my problem statement would be make a decision on the remaining array, and my current XOR would be this, right? If I don't include a current element, then my problem statement would be simply to generate what would be so far XOR for the rest of the array. Okay, now that I have both the XORs including the things and not including the things, then I would just have to return what is my overall XOR. So it will be summation of include and exclude. Okay, now that if I don't have any, now that I can, there will be a moment where I will be reaching the end of the array. The moment I have reached the end of the array, that means I have reached here, I have reached my end of the array. I should simply return what was the so far XOR I have, right? So I will just return the what is the so far XOR I have. Okay. So let's try to generate this subset XOR sum. Okay, from the starting element, and the initial subset XOR will be 0. Okay, so let's try to submit this. As you can see, all the basic test cases were passed. Let's also try to submit this problem. Yeah, all the test cases were also passed. Okay, so this is basically a minor tweak to the subset generation problem. Okay, so in the normal subset generation, there we will be actually populating the subsets. So here, instead of populating the subsets, we are just keeping track of what was the XOR so far we have. Okay, and then simply returning it. Okay, so yeah, that's all about this problem statement. Do subscribe to my channel for more such coding videos. Thank you.